Okay, it is time to review for the quiz tomorrow. The quiz tomorrow is about factoring and solving equations. We learned about several different kinds of factoring. I have sort of an example of each here, and we'll go through that. And then we learned about solving equations. Now we learned to solve equations by factoring. Then we learned to solve equations by completing the square. And then we learned to solve equations using the quadratic formula. That's what we learned yesterday. And then we'll have several problems that you can pick what you want to do yourself. So the way I want you to handle this is I want you to do one problem at a time. And every time you do a problem, I want you to check your answer against the answer key before watching this video. If you got it right, great. Go on to the next problem. If you got it wrong, watch the video for that problem only. And then go on to the next problem and do that again. Alright? Try to do it yourself. Check your answer. If it's right, go on to the next one. If it's wrong, watch the video for that problem. Look, like I always say, when you watch the video, do not watch the video with a pencil or a pen in your hand. Alright, if you get problem number 2 wrong, put your pencil down, go watch the video for number 2, and then see how it's done. And then pick your pencil up and go do number 2 yourself on the paper. Never ever copy from the video. Not even in class. Not even just for practice. You just don't learn that way. Alright, let's get started. Problem number 1. We're supposed to factor. Ladies and gentlemen, the first step of factoring is to look and see if there is a common factor. 3, 16, 12. There is no common factor. So, therefore, we will go to the next step. When you have a trinomial like this, it is probably going to factor as a binomial times a binomial. So we will get our parentheses ready. First, you look at the 3x squared, the first term, and ask yourself what times what makes 3x squared. Okay, so we started off looking right here. There's only one way to get 3x squared. 3x times x will make 3x squared. Alright, next we turn our attention to the 12. And you start asking yourself, well, what are the ways to get 12? And you know what? It's either going to be 3 times 4, or it's going to be 2 times 6, or it's going to be 1 times 12. Those are the only ways to make 12. Alright. Now, I cannot just immediately start looking for the 16. That only works when there's no number in front. Instead, I need to do some guessing and checking. So, I'm going to start with the 3 times 4. Now, a little shortcut that I taught you guys. I will not even try putting the 3 here and the 4 here as I tried 3 times 4. Why? Because if there's no common factor in the original problem, there should be no common factor in either parentheses. And if I put the 3 here, that makes a common factor, and that will not happen. So don't waste your time. So if you're going to do 3 and 4, the only way it could possibly work is if we do 4 and 3, because that doesn't create a GCF. Now, to see if this is right or not, check the inner and the outer. The inner plus the outer has to equal the middle. Alright. Let's see. I think I'll just do this in red. Inner, I've got 4x. So I like to put a little 4x right here. Outer, I've got 9 because I'm multiplying. Alright, I've got 9x. The middle that I'm shooting for is negative 16. Alright, so I guess I should highlight this because now we're looking for this guy. This is the last thing we do. So we're shooting for negative 16x. Is there any way to get negative 16x if I pick the signs right? No. The most I can make is 13, not 16. Okay, so that means 3 times 4 is not working. So I will go on and try 2 times 6. Okay, so let's start over a little bit. Starting over with 2 times 6. Alright, one more time. And am I going to try 2 times 6? Or am I going to try 6 times 2? Because I'll give you a hint, only one of those is going to work. Or I mean, only one of them has a chance. Am I going to go with the red or the green? I'm going to go with the red. Okay? If I did the green, then the 3 and the 6, there's a GCF there. So don't waste your time on that. So we will not do the green. Okay, so we're going to do the 2 and the 6. Okay, so we'll try 2 here and 6 here. Again, inner plus outer has to equal the middle. Inner, I've got 2x. Outer, I've got 18x. Can I make negative 16 out of this if I pick the signs right? Well, it appears so. I need negative 16. If I did a negative 18 and a positive 2, that would make negative 16. Positive 2, you say. There's my positive 2. And this negative goes with the 6 because that's part of the outer. And one last thing. I have to make sure that I'm actually going to get a negative 12 if I multiply these. Positive times a negative is a negative, so it checks out. So that's it. Now I can be guaranteed that this is the correct factorization for number 1. Alright, move on to number 2. What is the first step of factoring? GCF is what I hope you said just then. The last one had no common factor, but this one, 5, 25, 30, they're all divisible by 5. So when I recognize that there is a common factor, I'm going to bring that outside the parentheses. It's mandatory. It's not optional. Okay, so inside, let me put this down a little bit lower. So I'm bringing that 5 outside the parentheses. Now, when I bring out a common factor like this, what I'm really doing to find out what goes on the inside is I'm dividing. So that's why on the inside we will have x squared minus 5x plus 6. Alright, divide, divide, divide. Now this needs to be factored further. So I will keep the 5, right? Do not let anything bad happen to it, and we will factor this. Now x squared can only be x times x. 6, on the other hand, has 2 possibilities. First I will try 2 times 3, and then I will try 1 times 6. Okay? Let's start with 2 times 3. Okay, the inner plus the outer have to give you the middle. Inner, I have 2x. Outer, I have 3x. I'm shooting for middle of negative 5. Okay, what do the signs have to be on these? To make negative 5, I would need a negative and a negative. So that translates into a negative and a negative. Does that make positive 6? Yeah, negative 2 times negative 3 is a positive 6, which means that this is the correct factorization. Okay, I'm just going to show one common mistake that I see on this problem before I move on. So this is the answer. That problem's done, but I think this is useful to look at. Most kids see that I need to pull out that common factor. Okay, so maybe I'll do it up here. Most kids would have done that step, 5x squared minus 5x plus 6. Now, as we get ready to do 1 times 6 and 2 times 3, because there's no number in front, the leading coefficient is 1, we can do the shortcut of immediately looking at these pairs and trying to see which one can make 5 or negative 5. But in this case, it's a little tricky because both of them, if I add 2 and 3, I can get 5. If I subtract 6 minus 1, I can get 5. So a lot of kids will wind up trying the 1 and 6. They'll just notice that first sometimes. So imagine that we did that, just in case you're one of the people that did 1 and 6 and you're not sure why it's wrong. If we did 1 and 6, it would be like this. Okay, there's my 1 and there's my 6. Now, inner plus outer has to equal middle. So inner, I've got 1x. Outer, I've got 6x. And I'm trying to get a middle of negative 5x. Now, I can get a negative 5x if I pick the signs right. But the signs would have to be negative 6 and positive 1 in order to make negative 5. So there's my positive 1 and there's my negative 6. So far so good. The problem is that last thing we always check. We have to make sure that we're getting a positive 6 if we were to multiply these. And the problem is positive 1 times negative 6 is negative 6, not positive 6. So that's why this version would not work. And the other version is the actual answer. On to number 3. This one looks awfully short. Is there a GCF? No. Is this a difference of 2 squares? No. Alright, n to the third, p to the third. Those are obviously cubes. So maybe 512 is also one of my perfect cubes. When you first start your test, your quiz, I encourage you to generate a list of the first 10 perfect cubes by using your calculator and doing 1 to the third, 2 to the third, 3 to the third, as I have done. And then you can refer back to it as needed. Now, looking at this problem, you see the 512. Do you notice that it's right here on the list? 512 comes from 8 to the third power. So we could say that 8 is the cube root of 512. Okay, so with that in mind, we realize that this is the difference of 2 cubes. Now, I taught you that the way this works is it will always factor as a binomial times a trinomial, a 2-piece times a 3-piece. The binomial is just the root of these. Okay? N to the third obviously comes from n. Just keep the same sign, so I'll bring that down. We just saw that 512 comes from 8 to the third power, and p to the third power comes from p. So this binomial comes from just the root of all of these. Now, once you've got your binomial, you can use that to get your trinomial. Trinomial has 3 parts to it. It has a beginning, an end, and a middle. Okay? Now, I'm putting the beginning and end as both the same color because we're going to do those both at the same time. Basically, if I want the beginning and end, I'm just going to square the terms of the binomial and put them here. So if I square this, n, obviously that's going to be n squared. If I take this negative 8p and I square it, No, keep in mind that's negative 8p times negative 8p when you square something. Negative 8 times negative 8 is positive 64. And then p times p is p squared. Okay, so you just take each term of the binomial and you square it, and that gives you the beginning and the end. Now the middle term is going to be, you get that by multiplying these two together. So I'm going to multiply, okay, the two terms of the binomial, and I'm going to multiply it, but then I'm going to do the opposite sign. Alright, so if I multiply these, I'm multiplying n, times negative 8p. So if I multiply those together, I get negative 8 np. Okay, but right here I'm going to put positive 8 np because you do the opposite sign. And that's it. That's how you do it. Okay, it's really not that complicated. You take the roots, and that gives you your binomial. Square it, that gives you the beginning and the end. You multiply them together and take the opposite sign, and that gives you the middle. So that is how you do the difference of two cubes, or the sum. If this were addition, it would be the same thing. Okay, this would be positive, and then this would be negative. Many kids, it helps them remember if I refer to this. It helps to remember the signs by using the acronym SOAP. Alright, this stands for same, opposite, always positive. Because this sign is always the same, this sign is always the opposite of this, and then this sign is always positive. That's the A and the P. Alright, same, opposite, always positive. So that's SOAP if it helps you remember. Okay, this is taking too long. I need to go faster, but I don't want to lose you. I guess it's okay for you because you're not watching the whole video. You're just skipping around and watching the ones that you need. So hopefully you don't need them all, or it will take you an hour to watch this video. Alright, anyway, what is the first step of factoring? I hope you said, look for a common factor. Is there a common factor here? Yes, it's not super obvious, but both of these are in fact divisible by 3. Okay, so we need to pull out a 3 outside the parentheses. Maybe I better leave room. Okay, so I'm pulling out the 3. 3 times 25 is 75. So this is going to be 25x squared minus 3 times 4 is 12. Again, another way to look at it is dividing by your common factor. So you get this and this. Now that's important because now you can see this is actually the difference of two squares. So we will keep this 3 and we will continue to factor this stuff. So the difference of two squares should be quick and easy. You split these right down the middle. This is 5x and 5x. And 4 is going to be 2 times 2. Alright, it's always the even split for the difference of two squares. And it's always positive, negative. Okay, those should be your favorite because they're so quick and easy. So that would be it for number 4. Okay, any common factors here? Well, yes, there are. Not only are these both divisible by 3, but also an n is common to both. So that means I'm going to bring out 3n outside the parentheses. Okay, and just to be super clear, I will go ahead and show myself dividing by 3n, because this is what you really do. Okay, 27 divided by 3 is 9. N to the third power divided by n is n squared. 24 divided by 3 is 8. And these n's cancel out, so it's just 8. Now, can I go any further? Is this a difference of two squares, maybe? No, it's really close, because 9 is a perfect square and is the difference. But 8 is not a perfect square, so we're done. If this had been a 4, you know, or a 9, or a 16, or a 25, then I would have kept going, just similar to number 4. But 8 is not a perfect square, so we're done. That's the answer for number 5. Okay. Another type of factoring that we learned about was called grouping. And when you see 4 terms, you should try grouping right away. Alright, grouping was like this. We take the first 2 terms and we view them as one group. And then we take the second 2 terms and we view them as a group. Looking at each group, we're going to do the greatest common factor. So let's see. Let's look at this as this will be our blue group, and then this will be our yellow group. Okay, let's do the blue group first. You look and see what is the common factor here. I see a 5 goes into both, and both of these have an n, so 5n. So I will pull out 5n. Let's see, I really want to color coordinate this. Okay, now if I divide each of these by 5n, I'm going to get p minus 4. Okay, just to make it super clear, like I said, I'm dividing by 5n. The 5's cancel, the n's cancel, so I have p. 20 divided by 5 is 4, and the n's cancel, so p minus 4. Now, looking at the yellow group, and what's common? Well, both of these are divisible by 6, and they both have a p. So I'm going to pull out 6p. Okay, so plus 6p. Now let's see what that leaves behind. Alright, for grouping to work, it has to be the same as the previous parentheses. So I'm kind of hoping that it turns out to be p minus 4, or else I'm stuck. But let's not assume, let's check it out. If I do go back and I divide both of these by 6p, the 6's cancel, the p's cancel, and I have p. And then here 6 goes into 24, and I get 4, and the p's cancel. So it's looking good. Now, since these parentheses are the same, what you do is you bring them out. Alright? These parentheses themselves are a common factor. So p minus 4 is a GCF that needs to be brought out front. So you pull out the p minus 4 out front. You know, just like we pulled out, you know, the 3n was a common factor, so we dragged the 3n out front and that we left behind the leftovers. Here, p minus 4 is a common factor, and we undistribute it and put it in the front. Anyway, that's going to leave behind the blue stuff. So that's going to leave behind 5n plus 6p. And there, we did it. We factored it. We're geniuses. Okay, that's grouping. What else you got? Alright, so that was a little review of factoring. Okay, that was a little smattering of really all the different kinds of factoring that we learned about. Okay, now let's talk about solving. Notice that none of these expressions are equations. There are no equal signs anywhere. It's not equal to 0. It's not equal to 7. There are no equal signs. All right. Notice the directions say factor. Factor completely. Now, look at how the directions have changed, and look at how the problems have changed. This now says solve. We're using the word solve. Solve is not a general generic term that just means do the problem. Solve means we're going to find x. We're going to find values of the variable that make this equation true. You can solve an equation. You cannot solve an expression. All right, it would not have been appropriate to say solve these. You can't solve 3x squared minus 16x minus 12. You can factor it, but solving implies that you have an equation. So, how do you solve these? Well, we learned several different ways. One way is to factor. But in order to solve by factoring, we need these to be in standard form. In other words, standard form is like this: ax squared plus bx plus c equals 0. That is standard form. But the key thing here is we need x squared, and then x, and then the constant equals 0. So this is pretty close, but we need that 21 to be over there before we do anything. So let us subtract 21 from both sides, like so. So that is going to give us 2x squared minus x minus 21 equals 0. Okay, now we are ready to factor. So we'll factor this. Now, looking at the 2, that can only be 2 times 1. Okay, looking at the 21, there are two possibilities. It is either going to be 3 times 7 or 1 times 21. Those are the only two possibilities. Alright, so let's give it a shot. Alright, there are no common factors. So, as we try to factor this, okay, 2x squared can only be 2x times x. Okay, there's your 2 and your 1. Now, 21. Let's start with the 3 and the 7. I always start with the numbers that are closer together, and then I go to the numbers that are further apart. Okay, the ones that are closer together are just more commonly the answer. So let's start with 3 and 7. Now, remember, the inner plus the outer have to equal the middle. Inner, I've got 3x. Yeah. Outer, I've got 14. I'm multiplying here. Okay, outer, I've got 14x. I'm trying to get negative 1, because there's an invisible 1 right here. So I'm trying to get negative 1x middle. All I can control are the signs. Is there any way I'm going to get negative 1 out of this? No. If I add, I get 17. If I subtract, I get 11. There's no way I'm going to get 1. Okay, that didn't work out. Before I cross these out and try the 1 and the 21, if I were you, I would try switching places here. Okay, so if I try switching the places, okay, so I will try putting the 7 here and the 3 there. I'm just reversed to them. So let's see if that makes a difference. Inner plus outer has to equal the middle. Inner, I have 7x now. Outer, 2 times 3, I have 6x. Oh, this is looking more promising. Is there any way, if I choose the signs right, that this will make negative 1x? What color should I pick? Green is ugly, but, I'll do purple. If I want the answer to be negative, the bigger number needs to be negative. So, negative 7 and positive 6 will make negative 1. So guess what? There's my negative 7, and this positive 3 would make the positive 6 outer. So one last thing I must check. This is looking pretty good. Does negative 7 times positive 3 give me negative 21? Well, yeah, a negative times a positive is a negative. So there, I have factored it correctly. Alright, I'm just going to box this to keep it out of my way. Now, but we're not finished because we're solving now. We're not just factoring. If I was just factoring, I'd be done. But now we're solving, so we have to get all the way down to x equals this, x equals that. How do we do that, you ask? It's called the zero product property. We set these to equal to 0. So I'm going to do 2x minus 7 equals 0, and I'm going to do x plus 3 equals 0. I'm going to solve both of them, and I'm going to get two answers. So here, if I add 7 to both sides, that gives me 2x equals 7. If I then divide by 2, like so, then that gives me one of my answers. So I get x equals 7 over 2. Okay, that's one answer. Meanwhile, over here I will subtract 3 from both sides. So that's going to give me x equals negative 3. Okay, so these are the two solutions, 7 over 2 or negative 3. Okay, let's see what happens on number 8. Again, we need this in standard form, so let's subtract 16 from both sides. That is going to give me 25x squared minus 16 is equal to 0. Well, this is only two terms. Luckily, it is the difference of two squares, which is a pattern that we know very well, hopefully. Difference of two squares, you split these both down the middle. So this will be 5x and 5x, and 16, that's 4 and 4. So it's 5x plus 4, 5x minus 4. Okay, boom, that's automatic. Now the zero product property, so I'm going to do 5x plus 4 equals 0, and 5x minus 4 equals 0. Subtract 4 from both sides, add 4 to both sides. That's going to give me 5x equals negative 4. Okay, divide by 5, right? I guess I'll just keep going. That's going to give me x equals negative 4/5. That's one of my solutions. Over here I've got 5x equals 4. Okay, divide by 5 on both sides. So I get x equals 4/5. Okay, so those are the two solutions I get for number 8. Alright, number 9. Any common factors here? No. So I see this as a trinomial, so this is probably going to factor as a binomial times a binomial. 3x squared can only be 3x and x. 3 can only be 1 times 3. Okay? Now, am I going to try blah, blah, blah. Am I going to try 1 times 3? Or am I going to try 3 times 1? Because one of them is automatically impossible. Which one will I try? I'm going to do the red one. 1 and 3. Again, the 3 and 3 here would make a common factor, and that should be a warning to you. It's not going to be the one that has a common factor. Alright, if there's no GCF in the original problem, there should not be a GCF in the parentheses. So we'll do the 1 and 3 option. 1, 3. Yeah, don't waste your time. Now, inner plus outer equals middle. Inner, I've got 1x. Outer, I've got 9x. That's supposed to equal a middle, of positive 8x. Can I get this if I pick the signs right? Well, I want the result to be positive, so the bigger number needs to be positive. Smaller number, negative, that would give me 8. So there's my -1, and a positive 3 would give me the positive 9 outer. One last thing, does -1 times positive 3 equal -3? Yes. So I have in fact factored it correctly. Alright, now on to the zero product property. I'm going to take these two guys and set them equal to 0. So let's see, I've got 3x minus 1 equals 0, and I've got x plus 3 equals 0. Okay, add 1 to both sides, so I've got 3x equals 1. Subtract 3 from both sides, so I've got x equals -3. Now that's one of my answers right there. But this one I can go one step further. Alright, divide both sides by 3. Alright, so those cancel out. I get x equals 1/3. So those are my two solutions for number 9, 1/3 and -3. Okay, what else you got? Okay, so that was a review of solving equations by factoring. That's what that looks like. Now, we're moving on to a different method. Hold on, I got to take a sip of my tea. Raspberry zinger. Now, completing the square. What's today? Monday? Alright, so this is what we learned on Friday. Okay, yeah, this is what we learned on day 5. We need a special number to be here, this third number. And this positive 9, that's not it. So I'm going to move that just out of the way. Okay, so I'm just going to subtract 9 from both sides. So that is going to give me x squared minus 8x, leave a space, equals -10, don't you know? Now, alright, what is the magic number that will complete the square? Let's see, say it out loud. Okay, the magic number is 16. Okay, I'm going to add 16 to the left, and to keep the balance I'm going to add 16 to the right. Now, where did I get the 16 from? Okay, this number, we just put a little note here, has got to be half the middle. Okay, so what's half of the middle? Alright, that's -8, so half of that is -4. Half of the middle squared. So I took half of 8, well, -8, and I got -4, and then I squared it, and I got 16. So that's how you complete the square. You do half of the middle, and then you square that. And anything you add to the left, you have to add to the right. So there you go. Now, the point of completing the square with this special number, that guarantees that when I factor this, it's going to be the same number twice. So, same parentheses. So, this is going to be x minus 4, x minus 4. It's always going to be the same thing twice because of picking this number special. -10 plus 16, well, that's 6. The point of having the same factor twice is that I can write this as x minus 4 squared equals 6. Now, the neat thing about having it this way is that I can take the square root now. I can unsquare this with a radical. Don't forget your plus or minus, guys. Anytime you take the square root of both sides, the solution could be positive or negative. Alright, so that's going to be x minus 4 equals plus or minus radical 6. Nothing to be done with that. Have to add 4 to both sides, and we will put that in the front. So that's going to give me x equals 4 plus or minus radical 6. Okay, and because it's a radical, we really can stop there. Even though in the back of our minds it is healthy to realize that this really means two solutions for plus radical 6 and for minus radical 6. That's what it really means, but because you can't add these anyway, you may leave it like this. Okay, number 11. This one already it's left with no third number right here. So I'm just going to rewrite it to create a gap, just a space. So this will be x squared. Okay, let me just put a line here. So this will be x squared minus 10x, leave a space, equals negative 36. Now again I ask you, what is the magical number that completes the square? Alright, I hope you just said out loud 25, Mr. Burton. That's going to be 25. Okay, yeah, and if you did, you were right. It's 25. Now, if you were silent, maybe that you forgot about it's the half the middle squared. So half of 10 is 5. 5 squared is 25. That's why it's 25. If you add to the left, you got to add to the right. Okay, once again, once you complete the square, that guarantees that this will factor as the same thing twice. So this is going to be x minus 5, the minus comes from this, and x minus 5 again. Now if I add these together, this is going to be negative 11. So there. Now since these are the same as planned, then we will write them more compactly as x minus 5 squared equals negative 11. Now that we've written it so compactly, it is easy to take the square root of it. We can take the square root of both sides. Please do not forget what? Plus or minus. Okay, very important. Taking the square root of something that's squared takes away the exponent. So this is going to leave us with x minus 5 is equal to plus or minus. Now wait a minute. Square root of a negative number. Alright, you guys know you cannot take the square root of a negative number, right? Because nothing times itself gives you a negative number. Aw shucks, what's happening here? Tell you what's happening here. I had to turn on my TI-30 XS multi-view. I just wanted to show you that if you try to take the square root of a negative number, oh, domain error, wah wah wah, didn't work. Okay, but so in your brain you must remember that if you take the square root of a negative number, that's imaginary. Okay, so that negative sign in there is like a negative 1, and that negative is going to come out as an I. Alright, technically I is the square root of negative 1. So that allows us to leave the square root of 11 without the negative under it. Bring it out as an I. Alright, so plus or minus I root 11, not I plus or minus root 11. Some kids do that, and that's ugly and wrong. Nothing else I can do with the 11. If this had been a 4, I could have turned that into a 2, and it would be like 2i. But it's 11, so nothing to do with that. Anyway, we need to add 5 to both sides. and put it in the front. Okay, yes. So that's going to give us x equals 5 plus or minus I radical 11. And that's it. Alright? Obviously you can't actually add these together. It is worth noting that this really means two solutions. This really means 5 plus I radical 11 and 5 minus I radical 11. That's terrible 11. But you're allowed to leave it in this form for convenience. Okay, was there any more? Oh, there's another one. Okay, one more completing the square problem. Once again, this number is not the number that we want, so let's subtract it away. So that'll leave us with x squared plus 4x equals -1. Now, what is the magical number that completes the square, children? What is it? It's 4, isn't it? Why? Take half of the middle and square it. So half of 4 is 2. 2 squared is 4. Okay, and I have to add it over here as well. Yeah, that's great. Alright. So now when I factor this, this should be the same thing twice. So it should be x plus 2 times x plus 2, because 2 times 2 is 4. You get it. Add these together and I'm gonna get 3. Yeah. Yeah, anyway, so this is gonna make x plus 2 squared is equal to 3. And now it's time to take the square root of both sides. What do I have to always remember to do when I take the square root of both sides? Plus or minus, don't forget it. So that's going to give us x plus 2 is equal to plus or minus radical 3. Great. Now I need to subtract 2 from both sides and put it in the front. So that's going to give me x equals -2 plus or minus radical 3. Okay. That's it. That's the answer. Okay, I should say those are the answers, because once again this represents -2 plus radical 3 and -2 minus radical 3. Okay, so there's that. Alright, so that was a little completing the square. Kind of bummed that there were none of these that turned out to be regular numerical answers. Maybe one of the ones at the end. Alright, for now let's move on. Okay, solve these using the quadratic formula. Okay, I feel like I should write the quadratic formula down right here. Okay, here's how the quadratic formula works. To use the quadratic formula, you need to have an equation that's in this form. ax squared plus bx plus c equals 0. This is called standard form. I'm not going to write that down, but this is called standard form. Now, if you have a standard form equation, then the solutions can always be found using this formula. And it goes like this. I'm referring to this A, this B, and this C. That's all we need. So it's going to be opposite of B plus or minus the square root. Let's see, I think I'll do this part in purple. B squared minus 4AC all over 2A. Now, in one of my classes, we sang a little song to the tune of Frere Jacques, if you are familiar with that. And And in my other class we didn't get to because we ran out of time. But it was like this: opposite of b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Okay? I'm not going to sing that again, so you can play it back if you need to hear it some more. Because you need to memorize that. That's the point. Now, I made this part underneath the radical purple because it has a special name. The purple part is called the discriminant. Okay, and I want you to always calculate the discriminant first and then plug it in. So don't try to plug all this in at once. Calculate the discriminant separately before the rest of the problem. So here we go. This problem number 13 is already in standard form. Okay? It's already in the ax squared plus bx plus c equals 0. It's already in the right form. We just have to recognize that a is 1. It's invisible 1 that's right here. B is 8. And C is -1 because of that in the C position. Okay? So, I told you to calculate the discriminant first. The discriminant is b squared minus 4ac. Okay? So let's do that. Maybe I'll do that in purple. The discriminant is b squared minus 4ac. So that's going to be, okay, b squared. Well, b is 8, so b squared is 64. So I have 64 minus 4 times 1 times -1. Okay? Now I can do this in my head. Okay? And I can see that this is going to be 68. But some of you will need to type this in a calculator. Okay, so you know who you are. Do what you need to do. So b squared says 64 minus 4 times 1 times -1. Alright, now you definitely do not need the 1. You understand? We don't need this 1 right here. I'm just putting it so you can see b squared minus 4ac for teacher purposes. Okay, move it, calculator. Anyway, I hit enter, and sure enough, I get 68. So there you go. So the discriminant is 68. Okay, once you have the discriminant, then you can go ahead and solve the problem. The fact that it's positive tells me that I'm going to have 2 real solutions. But let's go ahead and find them. So I'm going to do the whole quadratic formula now. Again, the quadratic formula is opposite of b plus or minus square root. So opposite of b. So b is -8. B is positive 8. So I'm going to put -8 because it's opposite of b. Plus or minus square root. Alright, and then it's b squared minus 4ac. But that's the discriminant. So, you know, you can just take your discriminant and put it in there. Alright, all over 2a. Alright, a is 1. So that's 2a is just 2 times 1, which is 2. Alright, square root of 68. It's time to put that in your please don't put this entire thing in your calculator. I know that it will fit in your calculator, but your calculator will turn this around backwards, and sometimes it gives you decimals and stuff. Do not, please do not put this entire thing into your calculator. Just put the square root of 28 in your calculator. That's all. Okay, so if I do the square root of 68, I get 2 radical 17. Oh, I don't need that right now. So it was 2 radical 17. So this is going to become x equals -8 plus or minus 2 radical 17 over 2. Now, this is pretty much the answer except for reducing. You can reduce if there is a common factor between all 3 of these terms. Alright, and you can't mess with the thing underneath the radical. But in terms of the number in front of the radical and these 2 other numbers, if they are all divisible by the same thing, well, then you do it. Okay, and these are all divisible by 2. So we're going to divide by 2, divide by 2, and divide by 2. It has to be all 3 places. Can't just be these 2. All 3, and it has to be in front of the radical, not under the radical. So if I divide all these by 2, then I'm going to get, so that's going to be -4 plus or minus. These cancel out, so I just have radical 17. And these cancel out. Alright, 2 divided by 2 is 1. Don't put a 1 down here. That's like having 5 over 1. That's silly. That's just 5. So don't put the 1, don't put the 1. Where did that 5 come from? Look, I just made it up. Alright, forget it. It never happened. Let's move on. Okay, so this is the answer. Or I should say these are the answers, because once again, this really represents 2 separate answers. -4 plus radical 17 and -4 minus radical 17. But since you can't really combine them, you're allowed to leave it like this. Okay, what else you got for me? Number 14. Again, this is already in standard form. So A is -8. B is 7. C is 2. So let's do the discriminant. Wait, I want to do that in purple. That's not, still not purple, man. Alright, the discriminant is b squared minus 4ac. Okay, so that's going to be b squared minus 4ac. Alright, I highly recommend that you square this yourself. Alright, 7 squared is 49. So it's really, I'm going to go 49 minus 4ac. Okay, so 49 minus 4 times -8 times 2. That is 113. Okay, so the discriminant is 113. Okay, now that we know that, we can go ahead and solve the problem. Okay, so the solutions will be opposite of b. So opposite of that is -7. Plus or minus square root, and then the 113 goes there. Whoa, 113. All over 2a. 2 times a, that's 2 times -8. That's -16. This problem looks familiar. I feel like this was in your homework or something. Anyway, this is basically the answer, except for these negatives. We should cancel them out. And you know how I said we should do all 3, but this has a plus and a minus, so dividing this, by -1, because like technically I'm dividing everything by -1. -1. Okay, I messed that up a little. Alright, but I'm dividing everything by -1. But this is already plus or minus, so it doesn't change this. Alright, this is bothering me. Anyway, basically these signs cancel out. So it's better to leave this as x equals 7 plus or minus radical 113 over 16. Doesn't that just look a little cleaner? I mean, they are numerically equivalent, but this is just a little more simple looking. So this is how I want you to write your answer. Okay? And please understand one more time that this is really two solutions. It's 7 plus radical 113 over 16, and it's 7 minus radical 113 over 16. But you can leave it like this. Okay, number 15. One more quadratic formula problem. Now this is not in standard form, so we need to add 4x squared to both sides. Okay, and while we're at it, we need to subtract 12 from both sides. Alright, because I need 0 over here. So this is going to make, see, these are like terms, so 6 plus 4, so I'm going to give 10x squared. Okay, these are not like terms, so I will just write them next to each other. So negative 7x minus 12 equals 0. So we have this. So let's go ahead and do our quadratic formula. Keeping in mind that A is 10 and B is negative 7 and C is negative 12. No GCF. So first let's find the discriminant, because that's what we do. Alright, the discriminant, remember that is b squared minus 4ac. So b squared, so that's negative 7 squared minus 4 times 10 times negative 12. Now, it's better to recognize that this is 49, but if somehow you don't know that this is 49, it is okay to put this in your calculator, but you have to make sure you use parentheses. Okay, you have to use parentheses. Alright, better move it over there. Whoa, wrong thing. That's the wrong thing too. Man, I'm messing up. Okay, so if I'm going to type this in my calculator, say if I don't know my multiplication, if I don't know what 7 times 7 is, I probably have bigger problems than this. But negative 7, okay, you have to put it in parentheses. So it would be negative 7 squared minus 4 times 10 times negative 12. Okay, so I really could literally type it in as b squared minus 4ac, as long as I remember to put the b squared in parentheses. So that's going to give me 529. Okay, so now I can go ahead and solve the problem. Keep that in mind. So this was 529. So now let's find the solutions. So the solutions will be opposite of b. So negative 7 becomes positive 7 plus or minus square root 529. Alright, your discriminant, all over 2a. 2a. A is 10, so 2a is 20. So we've got this. Alright, do not put this entire thing in your calculator. Let's just do the square root of 529. Alright, square root of 529. 23. That was a perfect square. Good to know. Alright, so that's 23. So this becomes x equals 7 plus or minus 23 over 20. Now, you may not leave your answer like this. You're not allowed. We were allowed to leave the answer like this before because we had a radical. But we can actually add these. So you must keep going. Okay, so you must recognize that this means two things. It means 7 plus 23 over 20, and it means 7 minus 23 over 20. All right, plus or minus 23. Plus 23 minus 23. Okay, now if you're good at addition, 23 plus 7, you're going to know that that is 30. Okay, so that's going to be 30 over 20, which is just 3 over 2. So that is one of the answers. Okay, but you could have done this if you really had to. Make your fraction 7 plus 23 over 20. You could have done this. Okay, and you're going to get 3 over 2 just like I said. Okay, let's practice that for this one. 7 minus 23 over 20. Make your fraction 7 minus 23 over 20. That's negative 4 over 5. Okay, so these are my two answers. Boom. Okay, so that was a review of solving by the quadratic formula. So really, we have reviewed everything at this point. Okay, now there's a few problems here at the end for you to practice using the method of your choice. Okay, so that is what we will do. So look at number 16. Really, in all the methods except for completing the square, we want this to be in standard form. Now, completing the square is good to use when there's no number in front. Now, a problem like this, we could still do completing the square. It's just a little tougher. So I'm hoping that one of the other methods will work. So let's put this in standard form by subtracting 10 from both sides. So this will give us 2x squared minus 4x minus 10 equals 0. What is the first step of factoring? Look and see if there's a common factor, a GCF. Yeah, there is, right? They're all divisible by 2. So if I factor out that GCF, so if I pull out that 2, that's going to leave x squared, alright, minus 2x minus 5 equals 0. Now, as I imagine trying to factor this, I start to realize that, you know, if I did 5 times 1, there's no way I'm going to get 2 out of that. There's no possible way. Okay? So this is going to be unfactorable. It's unfactorable. So that means I really either have to do completing the square or the quadratic formula. Now, since I just finished doing 3 quadratic formula problems in a row, I'm going to go ahead and do this one by completing the square. Okay, so let's go. Let's complete the square. Alright, so for completing the square, I can leave that 10 over there. In fact, I'm going to leave it like this. 2x squared minus 4x, leave a space, is equal to 10. Now, watch out. This is one of the tougher ones because it's got that 2 in front, but you are responsible for this. Alright, this is not even a bonus type problem. This is one that you should be able to do. Okay, a common mistake is to do half the middle squared right now. Can't do that because of the 2 right there. You are going to have to factor that 2 out before you do half the middle squared. So this is what I mean. Alright, put that 2 outside of the parentheses. Okay, and divide everything by 2. Okay, so I'm doing this. Divide by 2, divide by 2. That tells you what goes on the inside. So this is going to be x squared minus 2x, and I'm still leaving a space here. Now that I pull that 2 out, and I just have a leading coefficient of 1, now, and only now, will I do half of the middle squared. Alright, so half of this is 1, and 1 squared is 1. So I'll put a plus 1 right here. Now, what am I going to add to the other side? Okay, a common mistake would be to say, oh, if I add 1 over here, I'm going to add 1 over here. That would be true if it wasn't for this 2 in the front. So when I put this 1 here, because I have this 2 in the front of the parentheses, I'm going to wind up doing the distributive property. And this 2 is going to multiply by this 1, and 2 times 1 is 2. So by putting a 1 here, it's like I'm adding 2, because 2 times 1 is 2. So I have to add 2 over here to balance this out. Okay, so then you can go ahead with the rest of the problem. So now this should factor as the same thing twice. This is going to be x minus 1, and this will be 12. So this, now I can write this as x minus 1 squared is equal to 12. Now, before we take the square root, we need to get rid of this 2. So let's go ahead and divide by 2. So divide by 2, divide by 2. So that's gone. Okay, so that's going to give us x minus 1 squared is equal to 6. Okay, and now we can take the square root of both sides. Alright, if I take the square root here and here, don't forget your plus or minus. Then we're going to get x minus 1 is equal to plus or minus radical 6. Whoa, running out of space. So I'm going to add 1 to both sides, put it in the front. So that's going to give me x equals 1 plus or minus radical 6. And that's as far as we can go. That's the answer. I mean, technically, this is 1 plus radical 6 and 1 minus radical 6. You should get the same answer if you were to do this by using the quadratic formula. Alright, but that's a good review for completing the square. Alright, this video is already an hour and 12 minutes long. But that's alright, because this video is not designed for you to watch the entire thing. But anyways, we just got a few more to do. Let's start by putting this in standard form. Okay, so I'm going to do that by subtracting 4x squared from both sides. And I'm also going to add 3 to both sides. Now both of these actually have like terms, so that's good. Alright, let's see if I can separate this out a little bit. Okay, so putting this together, that's going to make negative 3 x squared minus 3x plus 5, okay, is equal to 0. Alright, there's no GCF or anything. As long as there's a negative in front like that, I don't like to try to factor when the first number is negative. Okay, so, I think I'm just going to do the quadratic formula on this one. I could multiply everything by -1 and try to factor, but then it might not even factor. So, you know what? Quadratic formula. It's all about the quadratic formula. So, now that it's in standard form, what we know is that A is -3 and B is also -3 and C is 5. Okay, so let's start off by finding the discriminant. Alright, the discriminant is b squared minus 4ac. So b squared. So we're doing -3 squared. Excuse me, -3 squared minus 4 times negative 3 times 5. All right, b squared minus 4ac. Okay, what are you looking at? Let's see. So I know that this is 9. So to me, I like to just put in 9 minus 4ac. So 9 minus 4 times negative 3 times 5. Okay, I feel like that's the way to go. So the discriminant is 69. All right. From there, we can go ahead and find the solution. So the solutions will be opposite of b. So since I have negative 3, that will become positive 3. Plus or minus square root of the discriminant. So 69 goes in right here. Okay, all over 2a. So 2a is negative 6, man. 2 times negative 3, that's negative 6. Okay, now if you were to try to take the square root of 69, you would find that it cannot be simplified. So that's just going to stay that way. And you know what, really, this is the answer. Okay, that's it. Put a box around it. You're done. All right, there's no, even though these are divisible both by 3, there's nothing in front. Whoa. There's nothing in front of the radical that I can divide by 3. So you can't just do these two. It has to be all 3, and there's nothing here. So you can't do all 3. So that's it. That's the answer. Okay, number 8. So that definitely wouldn't have factored. So it's a good thing we didn't waste our time with that. All right, it's all about the quadratic formula. Okay, number 18. Let's go ahead and put this in standard form and see what we got. Let's subtract 40x from both sides like so. So that's going to give us 16x squared minus 40x plus 25 equals 0. I'm tempted to try to factor this. Alright, I'm definitely not going to do the quadratic formula. It's either try to factor it, or, you know, I'm just going to use the quadratic formula. Alright, you know, like if I don't know that it's going to factor, you know, like I always wonder, am I going to waste my time trying to factor it and then find out that it doesn't factor and then have to use the quadratic formula, when I could have just gone straight for the quadratic formula and be done. So given a choice, you will most often see me choose the quadratic formula. Alright, unless I can just look at it and factor it in my head almost immediately. Okay, so what we have here, we know A, B, and C, right? Let me draw a line here. Alright, so I know that A is 16. B is negative 40. C is 25. Okay, so let's find the discriminant. B squared minus 4ac. So b squared, so that's b is negative 40. So there's b squared minus 4a c. So I've got that. Alright, I'm gonna just put that in the old calculator. So can I move that over? Yeah. Alright, I'm going to type it in. And I'm even going to type this in this time. Negative 40 squared. Don't give me any trouble there. But I have to put that negative 40 in parentheses. B squared always has to go in parentheses if you're going to let the calculator do it. So b squared minus 4ac. There it is. 0. Ha! 0. Check that out. So the discriminant is 0. That means we're only going to get one solution, one real solution. So let's go ahead and find our one real solution. If I went to find my solutions, it's opposite of b. Okay, so b is negative 40. So the opposite of b is positive 40. Plus or minus square root. Well, the discriminant was 0, so that's going to really disappear. All over 2a. So 2a is going to be 32, because 2 times 16. Now, square root of 0 is 0. So really, you know, ignore this, alright? 0, you could just erase it. So really what I have is x equals 40 over 32. This is the one and only solution. This just needs to be reduced. Okay, these are both divisible by 8. Yeah, okay, so that's going to be 5 over 4. Now, say if you didn't realize that these are both divisible by 8. Some of you guys, let's be honest, do not know your multiplication table. So 40 over 32. You should learn those, by the way. It's not too late. Okay, just get some flashcards. You can use your phone. So 40 over 32. Boom, 5 over 4. Okay, that is the one solution to number 18. Alright, 2 more problems left. Alright, this is one of the longest videos I've ever made. And this is for classwork. It's not even a test. Anyway, let me just calm down. Let's see. Should I try to factor this one just for fun? Alright, I think I'll go against my better judgment and I'll try to factor it just for the sake of variety. But I'm going to be mad if it doesn't factor and then I wind up using the quadratic formula anyway. I definitely would not complete the square, or, you know, there's got this 2 there and this is an odd number. It would be ugly. Alrighty then. So 2x squared could just only be 2x and x. Okay, 4. Alright, it's either going to be 2 times 2 or 1 times 4. Well, you know what? It can't be 2 times 2 because that would create a GCF. So that's not possible. So I can forget the 2 times 2. So if it's going to be anything, it's got to be 1 times 4, like that. Okay, inner, I've got 1x. Outer, I've got 8x. Alright, I'm trying to get 3. That's not going to happen. So guess what? It wasn't factorable. So I just wasted my time. I knew it! I knew it. See, here I am trying to show you guys a variety of problems. But I should have just stuck with the quadratic formula. So that's what I'm going to do now. Alright, A is 2. B is 3. C is 4. Quadratic formula once again. So let's find that discriminant. Why do I always do it in purple? I don't know. Alright, b squared minus 4ac. So that's b squared minus 4ac. Okay, 3 squared is 9. So I'm just going to put 9 minus 4ac. Okay, b squared minus 4ac. Negative 23. No wonder it wasn't factorable. Okay, it's going to be imaginary. Alright, we're going to have 2 imaginary solutions. So no way was it factorable. So that turned out to be negative 23. Once you have your discriminant, you can go ahead and do the quadratic formula. So the quadratic formula will be opposite of b. So that'll be negative 3 plus or minus square root negative 23. Okay, the discriminant. All over 2a. 2 times 2 is 4. So kabam. So this is almost the answer, except for what do we do when we have a negative under the radical? Alright, you bring it out as an I. So I will have negative 3 plus or minus I radical 23. Alright, 23 is a prime number, so that cannot be simplified. So that's it. This is the answer. Okay, one more. Number 20. Alright, if there's a way to do this without doing the quadratic formula, I'm going to try it. Okay, because I've been doing a lot of quadratic formula today. So if I x squared, alright, so first of all, I'm doing, I'm sort of putting this in standard form. So minus 10x from both sides. Okay, so far that gives me x squared, minus 4x plus 5 is equal to 0. Okay, 5 times 1 is making 4. Alright, see, this is a good example. This is looking like it would be easy to factor. So I would not do the quadratic formula for a problem that it seems like I could just factor it in like 10 seconds. So x squared is x times x. 5 can only be 5 times 1. If I want a negative 4 in the middle, that will happen if I have a negative 5 and a positive 1. Oh, but it doesn't actually work, does it? I was so close. It was looking good, okay? Because inner plus outer has to equal middle. Inner, I've got negative 5x, right? Outer, I've got positive 1x. I'm trying to get a middle of negative 4. All that worked out. I was so happy. But the last thing you have to do is check the sign. And negative 5 times positive 1 gives you negative 5, not positive 5. So this did not work out. So that means this is unfactorable. Alright, so looks like once again I will have to do the quadratic formula. Except I'm not going to do the quadratic formula because there's this other method that we don't use very often, but now would be a good time. Completing the square would be, I think, quicker than the quadratic formula even. When there's no number in front, well, okay, when the leading coefficient is an invisible 1, and when the middle term is even, 2, 4, 6, 8, like that. So it would be pretty easy to complete the square. So let me show you how easy that would be. First, subtract that 5, get that out of my way. Get it out of my face. So that's going to be x squared minus 4x, leave a space, is equal to negative 5. What's the magical number that completes the square? Well, half the middle squared. So half of this is 2. Square it, you get 4. Okay, put that on both sides. Okay, this is going to factor as the same thing twice. Okay, x minus 2, x minus 2. Alright, that's equal to negative 1. That means I've got x minus 2 squared is equal to negative 1. So I take the square root. Do not forget your plus or minus. So that's going to give me x minus 2 equals plus or minus I. Just put I, please. I is defined as the square root of negative 1. And here I have the square root of negative 1. Please just know that that's I. Now I could go through some business about it being I times the square root of 1. And then the 1 goes away. I'm failing over here, by the way. Yeah, this square root of negative 1, look, the negative comes out as an I, but then, oh look, the square root of 1 is 1, and look, it's I. Okay, just get over it. Now let's add 2 to both sides. Put it in the front. So that's going to give us x equals 2 plus or minus I. Okay, and that is the answer. Alright, obviously this really means 2 plus I and 2 minus I. But since you can't add these together, you can just leave it like that. Alright, I think that's just as quick as the quadratic formula would have been. Not quicker, but just as quick. So that is it. We finally got to number 20. Alright, this video is an hour and 30 minutes long. So nobody watched the entire video. There's no student I have that's going to spend an hour and a half watching me do math problems. So you guys should feel bad for me. I don't have to feel bad for you, because I, unlike you, had to sit through every single problem on this video. Plus, it is 11:30 at night for me. That's why my voice sounds so ragged. Anyway, that was a nice little review of what the quiz is going to be like tomorrow. I hope it was helpful. I will see you on the next video.